In example 119, we're going to find a 99% confidence interval. For this situation, we've got a random sample of test scores for 100 applicants. So that's our sample size, n is 100. Showed a mean score of 72.6. That's a sample mean, x bar 72.6. We're going to use that as our starting point to create this confidence interval. We want to determine the 99% confidence interval, or level of confidence. 1 minus alpha is 0.99. For the mean score of all applicants, for mu, and we're going to assume the standard deviation of the test scores is 10.5. So our confidence interval starts with our sample mean, and then we need to figure out what is the maximum error. I mean, that's our big task to start out with. Find the maximum error. And we find the maximum error using this formula, z of alpha over 2 times sigma over root n. Now we know sigma and n, so we've got that part figured out, but we just need to know what is z of alpha over 2. So let's work with this level of confidence over here. 1 minus alpha is 0.99. That means that alpha is 0.01, and alpha over 2 is 0.005. So z of alpha over 2 is going to be the z-score for which the total area to the right is 0.005. And that means, of course, that the total area to the left is 0.995. And this is the area we're going to use when we look up at the table. We're going to find the closest we can get to 0.995 and the z-score associated with that. Z of 0.005 is, okay, let's go to the table. As close to 0.995 that we can get. All right, looks like we've got two values here to pick from, and those are equidistant from our goal. 0.995 is right smack dab in the middle, exactly in the middle between those two values, and of course in this situation we're going to pick the one with the higher z-score. So we're in the 2.5 row. The higher z-score is going to be the 0.08 column. 2.58 is z of 0.005. And now we have everything we need to fill in the missing information from this maximum error calculation. Z of alpha over 2 is 2.58 times sigma over root n. Sigma is 10.5 over root 100. Over root 100 is 10. So let's see, we get 2.709. Looking at the sample mean, we found that was rounded to the nearest tenth. So we'll do the same with our maximum error. So our maximum error that we'll use is 2.7. And now we can create our confidence interval. So x bar minus e to x bar plus e. So we have 72.6 minus 2.7, 72.6 plus 2.7, and now we just need to find these upper and lower limits on our confidence interval. 69.9 for our lower limit. $75.3 is our upper limit. So 69.9 to 75.3 is the 99% confidence interval for mu.